Okay, a few of you struggled with this question 12 when we're doing solution calculations, so I'm going to work through an example here. And reacquaint yourself, please, with the question. We've got a metal carbonate, and we're dissolving that, making a standard solution of that. And then we're reacting it with some hydrochloric acid. So straight away you're thinking, oh, carbonate plus acid goes to salt plus carbon dioxide plus water. And then we have to calculate the relative formula mass of this unknown metal in the carbonate, and then the relative atomic mass of the unknown metal. Okay, so that's what we've got to do. And there's generally two ways of doing this. One is to form a complete sort of plan in your minds before you start. That's possibly the best way, and you'll be able to do that after you've got done quite a lot of practice. But if you can't formulate that plan, remember that this is chemistry, and when you're doing calculations, if you're in doubt, you just calculate the moles of whatever you can calculate the moles of. So in this case, you can see straight away that we could calculate the moles of the hydrochloric acid. And once you've done that, then think, well, what can I do with that? And you could then calculate the moles of something else. Okay, and eventually you will actually get to the answer following that process. But what I'm going to do for you today is go through the whole mental plan first. Okay, so you're looking at this question, and you know that it's amount of substance question, right? And so we're always using the same two equations, right? So we're always using moles equals mass over mR. So I'll just write that up in the corner. And we're always, and this is involving solutions, so we're always going to use our concentration equals moles over volume. So we're always using those two equations, all right? And in this case, you'd start off by having a look at the balanced equation. So we've got a metal carbonate. Let's write it out here. So we've got M2CO3, right? And we're reacting it with some hydrochloric acid. And so you actually don't need the products of this balanced equation for the rest of the question, but let's do it anyway. But first, let's have a look. You've got a carbonate ion there, and you remember that a carbonate ion has a 2- charge, and we've got 2 ions of the metal in the formula unit, right? So we know that this is going to be a 1+ ion, right? So you've worked that out from the formula. In which case, it's going to react with a metal ion. It's going to react with 1 chloride ion, right? So your salt is going to be MCl. Okay, and you're going to get your carbon dioxide, and you're going to get your water, because you know that general equation from GCSE. All right. So if we've got a water here with 2 hydrogens in it, right, we need 2 hydrogens on the left-hand side there. In which case we've got 2 chlorides, and we need 2 of these, which has nicely balanced our metal already. Okay, so we're just going to do a final check on that, see that it's balanced, and yes, we think it is. Okay, so we've got that, and we notice straight away we've got a molar ratio of 1 to 2 for our carbonate and our acid. So what we're going to our first step is going to be to calculate the moles of hydrochloric acid, and that's the way you can write it out. Chemsheets writes it out slightly differently. This is the way I write it out. Either way is fine. So you're going to work out that first, and once you've done that, it's going to be clear that the next thing you need to do is work out the moles of your metal carbonate. Right, but notice that this is clearly a titration, and this is your tetra. That's what came out of your burette, and this is what you put with your pipette into the conical flask. All right, so our carbonate is going into our conical flask, and we're putting 25 cm cubed in there. So we're going to work out, if we work out the moles of hydrochloric acid in our tetra, right, then the moles of carbonate is the moles in 25 cm cubed. All right, not the whole 1000. All right, so then we're just going to have to do moles of metal carbonate in 1000 cm cubed. Yeah, so we can have that just by multiplying it up, because it's the 1000 cm cubed, decimeter cubed of solution is the same concentration as the 25 cm cubed aliquot that we took. Okay, so once we've got that, you're going to have moles, and we're now talking about this amount of mass. All right, that's the amount of mass that you got into this 1000 cm cubed. Okay, so we've got mass and we've got volume. All right, then we can calculate the MR. All right, so step 4 is going to be the MR of your metal carbonate. And step 5 is going to be the MR, let's call it the AR, because metal AR of the metal M. Right, that's going to be the last step. Right, so that's like the storyboard of the calculation. And if you can sort of form that plan before you start, at least in your mind or on a rough bit of paper, that helps. But like I said, it is also possible to just look at the question and say, well, look, I can work out the moles of that. I'm bound to have to do that, so why don't I just do it and see what happens, and then build it up, you know, like that. Anyway, we're going to do it this way. So moles of our hydrochloric acid, we're going to use one of these two equations, of course. So we could just rearrange our concentration equation. So we got moles equals concentration times volume, and our concentration from the question is 0.1, and our volume, remember volumes are in dm cubed, so we have to just convert our 27 cm cubed into dm cubed, and so that's going to come out at 2.7 times 10 to the minus 3. We can do that in our heads, don't need to get our calculators out, we can save some time there. Okay, so that's our concentration of hydrochloric acid. Sorry, that's our moles of hydrochloric acid, and that's reacting according to our balanced equation in a 1:2 ratio, right? So we've got half as much metal carbonate as hydrochloric acid, right? So our moles of our metal carbonate is half of our moles of hydrochloric acid. So we just write it like this, and that comes out at 1.35 times 10 to the minus 3. All right, we can do that in our heads as well. But that's just the amount of metal carbonate that's in the aliquot that we took in our conical flask. We have to, if we want to use the 7.46 grams, we have to multiply that up to see how many moles were in the whole volumetric flask. And so that is just a calculation like this. You're going to start off with how many moles you had in 25. Right, and you're going to multiply that up by 1000 over 25, and that is going to come out at 0.054. Okay, so now we've got the moles of our metal carbonate, and we can relate that directly to our mass of metal carbonate. So then we can use our moles equals mass over MR equation to work out MR. So we're just going to rearrange that equation for MR, and of course MR then equals mass over moles. Right, our mass is our 7.46. Our moles we've just calculated, and so that comes out at 138.1. Okay, so that's our MR of our metal carbonate, but the question is asking us for the AR of the metal. So this carbonate, the MR of a carbonate ion is 316 48 58 60. Yeah, so our twice of our AR is going to be the difference between 138 and 60. So we can then just half that and get the answer. Right, so the sum is 138.1. Take our 60 for our carbonate ion. Right, divided by 2 because we've got 2 metal ions in that formula unit, and that comes out at 39.1. which of course is potassium, which makes sense because then we know that potassium is a 1+ ion. Okay, so there's the work solution for that. Hope that helps.